Okay, in 8.3 we touched on the addition rule. We are going to look a little bit more into that rule, so make sure you print off your formula sheet. We're now going to do rule number 4. So if I have log base 2 4 plus log base 2 8, if I am adding, I can simply turn this into a single logarithm. I keep the base. I must have to have the same base to use the rules. And I'm simply going to take 4 and multiply it with 8. 4 times 8, which means I have log base 2 32. Now for the purpose of this, we were just trying to see that rule. I know the answer to this is 5, but all we were doing was turning it into a single logarithm. So the rule states if we have log A plus log B, the answer is log AB. Rule number 4 on your formula sheet, we'll want to be able to use all these rules interchangeably. We'll want to be able to go in this direction and also in this direction. So let's say we have 3 things. Remember, the base is unimportant. Log 1 plus log 2 plus log 3. So when working with equations, I'm always going to go down the page, but sometimes I'm just going to go off to the right. So I have additions. So we're going to turn this into a single logarithm. Log, and because they're adding, I'm simply going to multiply. So 1 times 2 times 3 is log 6. And feel free to check the answer on the calculator. Log 1 plus log 2 plus log 3 equals log 6 equals. Make sure those are the same. So now let's take a look at a division. So let's take log base 3 27 minus log base 3 3. So there we have a subtraction, and that turns into a single log. Keep the base, and we're going to have a fraction, 27 over 3. Now 27 divided by 3 is just simply 9, so we simply have log 9. Again, we can answer the question, what power do you have to raise 3 to equal 9? 2. But for this purpose, we're just turning them into a single log. So the rule states if I have log A minus log B, we can simply turn that into a division. Log A over B. Not log A over log B, not log A all over B, simply log A over B. Seen in your notes, seen on your formula sheet, rule number 5. So now let's take a look at some similar examples with more complicated positives and negatives. So if I have something like log 4 plus log 20 minus log 10, well, I'm going to turn this into a single log. So log. Now I'm working with fractions, so I'm just going to start off with an over, just like when I'm working with negative exponents or anything like that. I know there's going to be something that I'm multiplying and dividing. Now, this log 4 is positive. So the 4 goes on top. This log 20 is positive, so we times. This log 10 is negative, so the 10 goes on the bottom. And seen on your formula sheet, simply positives go on the top and negatives go on the bottom. So if I simplify this fraction, crossing off a 0 from the top, we simply get log 8. So there are a whole bunch of examples that we can do with numbers. Just remember, positives go on the top, negatives go on the bottom. Feel free to look through a couple more examples in the notes and make sure that you check your answer on the calculator. Let's take a look at a very similar example with letters. Log A plus log B minus log C. Well, I'm just going to turn that into a single logarithm. So A is positive, A goes on top. Log B is positive, times B on top. Log C is negative, C goes on the bottom. So another very similar example, we have log A minus log B minus log C. Well, that is equal to a single logarithm, and I'm going to start off with my over. So A is log A is positive, so A goes on top. Now log B is negative, so B goes on the bottom, and C is negative, so C goes on the bottom as well. Feel free to take a look at the notes and see all of these examples worked out. Let's go back in the other direction with the question we just figured out. So we have to make sure that we can go back and forth with all of these different rules, changing from a single log to a multiplication or addition and subtraction of logs. So now going back in the other direction, we have log A over BC. So as you can see in the notes, there are multiple different ways to solve this. I'm going to do it in the simplest fashion. A is on the top, so it'll be a positive log A. B is on the bottom, so it'll be a minus log B. And C is on the bottom, so it'll be a minus log C. So as you can see, sometimes we go from an addition to a single log, and sometimes we go from a single log to an addition and subtraction. Let's take look at a couple of examples with variables. Log x plus log x. Well, I'm adding, so I can simply turn that into a single log, and I can multiply the things together. X times x is x squared. Let's take a look at another example. Log 3 plus log x plus 1. Well, I'm adding, so I can turn into a single logarithm, and I'm simply going to multiply 3 times x plus 1. Now, I'm going to circle that answer. Now, the question is, should I distribute this 3? Well, I could, but I just have to refactor it back anyway, so I'm not going to. It may be useful to distribute that 3 in the future, but right now, it isn't. Another example of additions, log of x minus 2 plus log of x minus 1 is equal to, well, I'm going to turn that into a single logarithm and multiply these together. Excuse me, plus 1 in the notes, plus 1 in the notes won't make a difference, turning into a single log. In the notes, I have actually multiplied out this product of binomials, but not exactly necessary. So what about the subtraction rules? Well, let's take log of x cubed minus log of x squared. Now, this time we have a subtraction. So I'm going to turn it into a single logarithm, and it's going to be a division. And I'm going to put x cubed on the top, I'm going to put x squared on the bottom, and when I simplify, I get log x, grade 9 exponent laws. So let's take a look at another example of subtraction. Let's take log of x squared minus 1 minus log of x minus 1. Well, that's going to turn into a simple single logarithm again, plus 1 like in the notes. Now, x squared minus 1 is a differences of squares. So I can simplify that to be log of x plus 1, x minus 1, over x plus 1. The x plus 1's cross off from the top and the bottom, and I'm left with a single logarithm of x minus 1. So remember, we're just building up on these different rules. We're figuring out how to use these rules. We need to be able to use all of the different rules on the formula sheet interchangeably whenever. So we're going to be doing each of these different rules going forward in word problems, and we don't want to go back and have to review the rules each time. Okay, let's do an application of Rule 4 and 5. So let's say, for example, log 5 is equal to m, and log 7 is equal to n. Well, let's say we have a question like log 25. Well, I know that 25 is 5 squared, so I'm going to replace 25 with 5 squared. Now, rule number 2 says I can cross off my exponent and bring it down in front. Now, I already know that log 5 is simply just equal to m, so I can replace log 5 with an m and carry everything else down. The answer is just 2m. What if I have log of 35? Well, here we can use rule number 4 that we learned last time and separate it into a multiplication. Separate 35 into a multiplication, 5 times 7. Then we have a multiplication, so we can separate it into an addition of logs. Now I know log m for my given information at the top. Log 5 is m, and log 7 is n. So the answer is just simply m plus n. Let's take a look at log of 350. Well, that is log of 5 times 7 times 10. Now, why is that good? Well, I can separate that to be log 5 plus log 7 plus log 10. Now, I know log 5 is simply m, and log 7 is simply n, and log 10, well, I know that we have a base of 10, and what power do you have to raise 10 to equal 10? 1. The answer is m plus n plus 1. Okay, going in the other direction, what if I have something like log 5x? Well, that is a multiplication. I can separate it into an addition. And I simply know from my given information at the top that log 5 is simply just m, so the answer is m plus log x. And I can't simplify log x because I wasn't given any information. Let's take something interesting. Log 0.49. Well, I have to be a ninja with my decimals and fractions, and 0.49 is 49 over 100. So I can simply call it 49 over 100. Then I have a division, so I can turn that into a subtraction. Log 49 minus log 100. Now 49 is just 7 squared, so I can replace 49 with 7 squared. And I can leave log 100, but I'm going to put in the base of 10 if you don't see it. Now this 2 I can bring down in front, and I know log 7 from the given information at the top is n, so we simply have 2n. Now what power do you have to raise 10 to equal 100? Well, 2, so minus 2. So we need to be able to use these rules in all different ways, making sure that we can separate based on a multiplication into an addition, or combine, or change from a decimal into a fraction, and really good with change of base. And feel free to see the rest of the rules on that page, all sorts of different rules, when we use them and why.